This is lesson 5. We're going to be finishing up animation in this lesson, and we really don't have too much more to do, just talk about some mouse events. So let's get started. So without user interaction, we can still do animation like we did in the previous homework and lecture, but it's just simply painting a picture or telling a story. It doesn't really involve any interaction from the user, and so we have this capability. We might as well make use of it. So we can use the keyboard or the mouse, and we can detect events that happen when somebody presses a key on the keyboard, or when somebody uses the mouse and moves it, or clicks on something. We can look for those events and then act upon them. And then what this does is this allows us to do many more things with interacting with users, like games, education tools, training, surveying, voting. So it just opens ourselves up to a lot more possibilities. So to interact with the user as a programmer, we need to do a couple of things. First of all, we need to detect what it is that the user did. Click, hover, press a key, that sort of thing. These will capture with events. And we also have to find out where they are. Pretty much the location of the mouse pointer. Doesn't really apply to keyboards. And then we want to know what objects were involved, the objects on the canvas. So this is going to require you as a programmer to find that out. You have to poll the events and then compare the state and location of the object. So to try to detect what happened, we can use these events that are built into jQuery. We've already seen this. You've already done this in the previous homework assignment, where you had canvas.click, and that allows you to put in some code that will respond to events that happen. There's click, double click, mouse down, mouse over. Mouse over is used for, like, if they hover over something, or mouse leave if they stop hovering, and so forth. There's a lot of them you can look up. We're just going to use the mouse click in this next homework, but I invite you to look at the other things that you can do. There are also keyboard events like key down, key up, and key press. Surprising that you need all these different ones, but there's just some small differences. If they just hold the key down, it'll fire an event. It'll fire the key down event. And when they let it up, it fires the key up event. And then key press is both of those things put together, but it returns different codes, and you need to look that up. These are good things to use, though, in the future. If you decide you want to use these in a project or something, you should investigate it some more. To find out where something happened, we use a parameter that comes with the mouse events. So a typical call would be, canvas.click. I'm sorry about that. Canvas.click equals function E as a parameter. You put something in there, you call it event. You can call it whatever you want, but it'll pass that event object. And so that contains information about the mouse at the time that it was fired. E.pageX is the X location, E.pagey is the Y location, and that's what we're going to be interested in. So now to find out what if a particular object was chosen or selected or whatever. So this is what you as a programmer have to do. You have to determine what the interaction was. You have to find out if a user clicked or hovered over, or that sort of thing, in relation to an object. So you have to check every single object, and that's why we use arrays or some sort of structure like that. It makes it easier to iterate through them. And then determining the interaction depends upon the shape of the object, and we'll go through a couple of different ones. So first we'll talk about rectangles. Those are the simplest. If we've got a rectangle here, that's upper corner is at coordinates x1, y1, and its lower right coordinate is x2, y2, then it's just simply checking to see if it's between x1 and x2 and between y1 and y2. So if it's true that the x and y's are between these coordinates, then it's within the rectangle. Otherwise, it's not. So that's pretty straightforward. Circles are not that much more difficult. If we've got a point, let's say this green or red dot is x1 and y1, and we've got a circle whose center is xy and the radius is r here, then we can check to see if this point is within the circle or not by plugging that into this formula. And if this value on the left-hand side is in fact less than or equal to the radius squared, then we conclude that it's inside the radius. Now other shapes are a bit harder, sometimes a lot harder. Just to give you an idea, we'll talk about triangles, but I'm not going to get into anything other than that. So if you want to, you can use these two functions. Actually, the one function inside try here makes use of the second function. The second function up here, try sign, what this does is this just returns a true or false. It's kind of a, well actually it returns a negative number or a positive number, depending on what side of the line. The line is given by x1, y1, x2, y2, and then the point you're looking at is xy up here, those parameters. So we do this for each one of these different lines, and it and what this does is it tells us which side of each one of these lines that this is on. So that it turns out that if all of these things are negative, if all of these are negative, then it's inside, or if they're all positive, then it's inside of this triangle. So we just calculate a Boolean expression for whether this is less than 0 on all of these things, and then we check to see if these things have the same sign. And if they do, then it's inside. The last thing to consider for these interactions in advanced animation is just the other forces they can play on your objects. So these things can affect the direction and the speed. So direction and speed are really controlled by acceleration. So if you have variables that represent the x and y acceleration, you can use those to simulate things like gravity and friction and wind and other forces. So this is just a matter of sort of using your imagination to have it affect the objects in the way that you think is most natural. Okay, the last thing to talk about today is the homework assignment that we have. And for this one, this isn't formatted nicely, but if you go out to the web page and look at the assignment, it will have the same content, but be a little bit more better formatted. So in this assignment, what you're going to be doing, I'm just calling it a game of catching bugs. So think of these balls that are flying around on the screen as little bugs, and then the user has to try and catch them. We're going to have 2 or 3 of those on the bugs on the canvas, and then the user has to try and kill those by clicking on them. So to make it more interesting, we're going to have them move in different types of patterns, and the user has to click within the circle in order to kill it. So as they click it, you'll remove it from the canvas and look like it's killed. Alright, so these are the instructions. Bug 1's going to move in a sine wave type of pattern. That's it for that one. It'll bounce back and forth off of the left and right walls. Bug 2 is going to move randomly. So what I've done is have it pretty much move in a constant direction. You know, if it's moving to the right, it's going to continue to move to the right. But then 20% of the time, I'll change the direction, either up or down. So this is where you change that acceleration variable. And then finally, bug 3, it's going to just move like a typical ball, bouncing off the walls. But you're going to start it moving pretty fast and then slow it down every time it bounces. So every time it hits a wall, it's going to slow down, making it easier for the user to click on it, but In the meantime, there must be the user could sometimes lose. When the user clicks on the canvas, you'll have to check to see if they clicked inside one of the circles. If they did, then you're going to remove that bug from the array of bugs. When it gets down to 0 elements, then give them an alert that they've won. And then you can also have a triangle in the middle of the canvas. This is how they lose. If any of the bugs makes it inside of the triangle, then the user has lost. Okay, so I'd like to give you a quick demonstration on what your homework should look like. I'm going to start this up. You can see that I've got the triangle in the middle, but I've commented out the code that checks to see if something has entered it or not. The purple ball is the one that's moving like a regular ball, but it's slowing down every time it hits a wall. The blue one is moving randomly, and then the red ball is the one that's moving in a sine wave. And you can tell that if I click on one of these balls, I got that one, so it disappeared, and so forth. If I get them all, it'll show me that I've won. Okay, here's another demonstration to show. I put the code back in there that will make me lose if one of the balls goes into the triangle. So I'll start it up again, and before I even get a chance to do anything, the purple ball went inside the triangle, so I lost. Okay, in this last example, I uncommented that code, so it should I lost. I'll try it again. I have to try and get that purple one before it gets... There, got it. So now all I have to do is get these other two balls or these other two bugs, and I should win the game. You can tell I'm not a very good video game player. There we go, and finally got that one, so I won. Alright, so all the information's up on the website. If you have any questions, let me know.